Hello everybody. In this video I would like to talk about using AI, specifically Cognotik, my open source agentic development platform, for professional software development in high-scale projects.
Welcome to this presentation on component-based design and AI-assisted strategy development. We'll explore how breaking complex systems into manageable pieces, combined with AI capabilities, creates a powerful development paradigm. This presentation covers architectural principles, design patterns, and practical applications in modern software development.
Before we get into applications and using the tool, let's discuss some fundamentals first.
Modern software systems face an inherent challenge. As functionality grows, complexity becomes overwhelming. Component-based design addresses this by breaking complex systems into smaller, manageable pieces. Each component has a single, well-defined responsibility, making the system easier to understand, modify, and extend. This approach prevents changes from cascading unpredictably through the system. These three benefits form the foundation of component-based design. First, decomposition makes complexity manageable by creating clear boundaries and responsibilities. Second, isolated interfaces enable comprehensive testing without external dependencies. Third, reusable components reduce duplication and accelerate development across multiple systems. Together, these benefits create systems that are easier to understand, maintain, and extend.
So now let's take a look at the Cognotik project itself, which applies the strategy pattern in a number of ways. First, you of course have in settings, you have a number of API providers, and each of these API providers then provide a number of models for chat, images, and other purposes.
The strategy pattern is a design pattern that encapsulates different algorithms behind a common interface. This allows the system to select and use different implementations at runtime without changing client code. The pattern is particularly powerful because it enables context-aware selection, runtime adaptation, and easy experimentation with different approaches. It's also highly suitable for AI development because each strategy has a well-defined interface that AI can easily understand and generate.
And then we have the task type strategy library. Think of these tasks as self-describing modules that can be used by AI, but they can also be used by the application directly. Each of these task types is sort of a mini application. It may involve multiple rounds of AI conversation. It has a user interface. It may have long-running threads. It may even spawn other processes. Let's take a look at a writing package, which contains a number of task types that are designed for writing various types of content. Now, the names are fairly self-explanatory, but let's improve the documentation. We can select all of these files, right-click, Cognotik, macros, generate documentation. This processes each file independently, and it can produce either a single documentation file or a set of files where the files are named according to the input file name. Let's add some additional instructions. Create user documentation. Provide mermaid diagrams to illustrate data and logic. Let's give it a distinct output name. Let's say writing task types. We'll put it in the docs folder and press OK. You can watch the process as a background task.
AI systems bring three unique capabilities to software development. First, they can process vast amounts of code consistently without fatigue, applying patterns uniformly across entire systems. Second, they operate in semantic vector spaces where meaning is encoded as geometric relationships, enabling them to understand code structure and suggest improvements. Third, they're trained on enormous amounts of code and documentation, giving them access to patterns and best practices from across the industry. Cognotik demonstrates the strategy pattern through three major strategy families. The API provider strategy allows switching between different AI service providers. The patch processor strategy handles code changes with different matching algorithms. The task type strategy defines 26 plus different reasoning and execution patterns. Each family shows how the strategy pattern enables flexibility and reusability in real-world applications.
All right, let's take a look at the document. It looks pretty good. Nice UML mermaid diagrams. Now the next thing we're going to do is we will select just that document, which is, let's see how long it is, about 6,000 lines, which is substantial, but definitely less than the entire code base that it represents. We're going to right-click it, Cognotik, Code Chat. And now we are going to ask the AI, now that it has a summary of our existing library of writing tasks, propose 5 new writing task types. We'll take a look at our documentation and attempt to produce some new ideas. All right, let's look at some of our ideas. Research paper generation. I'm kind of surprised we don't already have that. Let's go with that. Now, for cutting and pasting purposes, I find selecting the raw markdown works better. We're going to select that item, and we will go back to our IDE. And now we will select 2 or 3 examples that are close to the new type of task that we want to generate.
Agentic development means AI systems actively participate in strategy development. AI can generate documentation that stays synchronized with code, suggest new strategies that would be valuable, refactor code consistently across all implementations, generate comprehensive test cases, and automatically fix failing tests. This transforms development from a manual, labor-intensive process to an AI-assisted, scalable system that maintains quality while growing exponentially.
Let's see. Report generation, native generation, and its associated reasoning tasks. Right-click, Cognotik, modify files. Not that we want to modify these files, but we want to make a new file. And now we say implement this idea. And then we paste in the idea. Haiku will think about it and come back to an implementation.
The time difference between traditional and AI-assisted development is dramatic. Traditional development requires a week or 2 per strategy because each step must be done manually. AI-assisted development compresses this to 1 to 2 hours because AI handles implementation, testing, documentation, and refactoring automatically. This 10x acceleration in development speed enables rapid innovation and experimentation.
All right. That all looks reasonable. Let's check back in our IDE.
Oh, bless.
And the compiler likes it. And there we have it. A completely new generation task created using the power of analogical reasoning. Now, the reason this worked so well is because the AI is very good at following examples and drawing analogies. So when we linked it to some example tasks, even though it was a fairly novel framework that was not probably in its training data, it was able to follow those minimal examples to generate new functionality.
When component-based design meets AI assistance, powerful synergies emerge. First, you can scale to hundreds of strategies without overwhelming complexity because AI maintains consistency automatically. Second, quality is consistently high because patterns are applied uniformly and documentation stays synchronized. Third, innovation accelerates dramatically because new strategies can be developed in hours instead of weeks. This represents a fundamental shift in software development. By combining component-based design with AI assistance, we create systems that are easier to understand, maintain, and extend. Complexity is managed through clear boundaries, flexibility is enabled through interchangeable strategies, and quality is maintained automatically. Innovation accelerates dramatically, and scaling becomes achievable without proportional increases in effort. This is the future of software development.